All right, our first video on the fundamental theorem of calculus is going to really talk about the relationship between big F, so the antiderivative function, and little f. And remember that we need to know that if big F is our antiderivative, then it must be true that if I take the derivative of the antiderivative function, I get back to my original function. And I want to demonstrate this thought with the sine graph. So if I'm trying to find the integral from 0 to x of sine of t dt, and I'm going to go ahead and map out the sine graph here. From 0 to 4 pi. So this is 2 pi, and each one of these is pi. Okay. It just so happens that the area from 0 to pi over 2 is 1, and each piece of this is symmetric. And so if I wanted to find like numbers on the graph of f, 0 would be the integral from 0 to 0, so that would be 0. Pi over 2 would be the integral from 0 to pi over 2, so that's going to give me an area of 1. This up a little bit here. When I get to pi, I'm going to get the area from 0 to pi, excuse me, is 2. Let's just do a few more of these. I get 3 pi over 2. Now I start negating that area, so I go back to 1, and then at 2 pi, all of that area, 0 to 2 pi, all of that area is now negated, so I'm back to 0. So if I were to graph big F, I would have 0, 0, pi over 2, 1, pi, 2, 3 pi over 2, 1, and 2 pi 0, which is the negative cosine, we'll keep this of x graph, moved up 1. Well, if I then want to find big F prime, I'm going to take the derivative of negative cosine. And so notice if I take the derivative of an integral, they just cancel out essentially, and you replace your variable with x. And that's what our formula right here, our theorem, says that we can do. So let's look at a more complicated example. On this one, I'm actually not going to have a formula to be able to integrate this. But if I just needed to find the derivative, I need to just find g prime of x. Then that's the derivative of this integral. These cancel, and I need my independent variable to now be x. So g prime of x is 1 over x cubed plus 1. Now, if you end up having a bound that is not just x, we do have to use chain rule. So on this one, if I'm taking big F prime, so I'm taking the derivative of 1 over root x sine of t dt. It is true that these two still cancel, and I need a variable here that it has an x in it, because this is big F prime of x. This is what our theorem tells us we can do, but I still need to take the derivative of the bound. So big F prime of x is going to be sine of root x, and then I need to multiply that by the derivative of the square root of x. And that's going to be my final answer. And you might want to put it as sine of root x over 2 root x. Resist the urge to want to cancel those things. That is not how it works, right? Sine has to have an argument on the inside. It's the sine of root x, not times root x. So that's a function in and of itself. Leave it alone.